So, hello, sir. I am Jeannie Bayan, and together with Kaden Zerda, we are here to present our project. So, our project is a discrete event simulation of a six-way intersection inspired by the complex traffic patterns at Chino Roces Avenue. So, we out to understand how different factors, from traffic light timing to pedestrian behavior, affect congestion and vehicle wait times. And our goal was to build a virtual model to test traffic management strategies without any real world disruption. So to build this simulation, we used a powerful Python library called SymPy, which allowed us to create a discrete event model. So this means we didn't simulate every single second, but instead we focused only on key events, like a car arriving, traffic light changing, or a car leaving the intersection. So this made our simulation efficient and highly focused on the core problems we modeled. So we modeled six directions of traffic and a central traffic light that controls all of them. So here's a quick look at our main components, which is the car class, which represents each vehicle and with its own speed and direction. And then there's the traffic light controller, which manages the signal phases, which cycles through north, south, east, west, and then the two diagonal directions. So each car entering the system becomes a process that waits for its green light and may experience delays from pedestrians or other cars changing lanes. So we wanted to answer three questions. So first is how does the traffic light cycle time affect average wait time? And then second is do pedestrians and cars changing lanes cause significant delays? Third is which combination of settings create the best and worst traffic flow? So we we looked at how each variable performed on its own and found out that the traffic light cycle had the most significant impact. As the cycle time increased from 10 to 30 seconds, the average wait time jumped from about 7 seconds to over 19 seconds. So this shows a clear linear relationship, which means longer cycle mean much longer waits. So you can see that in this bar chart. And then we were surprised to find that car speed had no noticeable effect on average wait time, as you can see in this bar chart. And then we found that both pedestrians and cars changing lanes cause small but measurable delays, as you can see here. So as you can see, there's some changes there. And then we simulated all combinations of all the variables, and we found out that the fastest scenarios all had one thing in common, which is a short 10-second traffic light cycle, and the absolute best result came from a 10-second cycle with no pedestrians or lane changing. So on the other hand, the slowest scenarios were all a combination of long 30-second cycles with pedestrians and cars changing lanes. So this shows that reverse traffic happens when a poorly timed light is combined with common real-world delays. So that's it for our process. We will now move with Aiden, who will discuss our summary and insights for our project. Thank you, sir.